Thank you. Welcome, everybody. Will and I are super excited to be here to present Nemesis 2.0, building an offensive VirusTotal. So just a little overview of what we're going to be talking about. We're going to start off with a little introduction to ourselves and what the problem set that we're dealing with. Going to dive into Nemesis 1.0. So Nemesis isn't a new project. We've been working on this for a while now, and talk about some of the lessons learned and why we decided to rewrite and do Nemesis 2.0, and then talk about some of the things that we are going to be diving into the future.
Yep. So my name is Will Schroeder. I go by Harmjoy on Twitter and GitHub and all the socials. I am a security researcher at SpectreOps. Been with SpectreOps kind of since the beginning. Been working with this guy and several others. So we do a lot of offensive research. Don't do quite as many ops as we used to, but still we kind of came up as a red teamer. Been building a lot of offensive tools for a while. So I was one of the people that helped co-found Bloodhound, the Veil framework, Empire. I was the primary author for Rubius, and then I was one of the co-authors for the Nemesis project.
And my name is Chagolla-Christensen. I go by Tifkin on Twitter. Like Will said, I've been with SpectreOps since the beginning as well. Been doing red teaming for the last 10 or so years. Got my start doing game hacking back in the day. But my passion's definitely on the offensive side and just trying to break into things and optimize workflows as much as we possibly can to do while doing that. So we're going to be talking about Nemesis. Nemesis, what is it? Well, as it says here, it's a centralized data processing platform that ingests, enriches, analyzes files collected during an offensive security assessment. Basic idea is it's going to take files in and do a crap ton of enrichments on it and help you out as an operator when you're doing red teams. You can think of it kind of like an offensive VirusTotal. There's a lot of value that comes from VirusTotal on the defensive side, and we wanted an equivalent tool on the offensive side as we're doing our assessments. So we will dive into what was Nemesis before and why it necessitated a Nemesis 2.0 rewrite as well. So our kind of vision here with what Nemesis is to provide automation, of course. So there's a lot of opportunity for automation when you're just looking at the file triage problem. During assessments, we analyze a lot of files. In order to do that, there's command line tools we could use. There's GUI-based tools that we could use. We can convert and transform those files in a lot of different ways in order to learn about them. Think like reverse engineering tools, something as simple as running strings on a binary, opening it up in a text editor, opening up a Word document in a document viewer. Those are all things that we have to do when triaging files, and it just takes time to do all that. Scaling. So we want to increase both the breadth of our analysis, so how much we can actually analyze, as well as the depth of our analysis of files. So how deep do we actually look at that? So a lot of times when we're downloading files as an operator, we download it, maybe open it up a text editor. If it's binary, we just kind of, throw it away. And then if it's a text editor, maybe we'll read through the code real quick, try and figure out what it's doing. And if it's useful, we'll use it, but a lot of times we don't end up doing anything with it. So maybe there's additional analysis we could do there. When it comes to the actual analysis, a lot of the data that we're working with is scattered across a bunch of different tools or teams. So when we're doing assessments, we oftentimes are using several different agents. So we're downloading and interacting with files from a bunch of different locations. It could be from SharePoint. It could be we're copying, we're working through like a VDI session or over RDP. So this data may be coming in through a lot of different forms, and we want to be able to analyze it consistently, irregardless of the tool that we're using. And then some continuity. So over time, we want to take what we've learned from our assessments and be able to apply that so that future assessments can leverage what we've learned, as well as maybe you start an assessment week 1, but you're doing an assessment, the same assessment still going on maybe 6 weeks later. You still want to be able to analyze all that data that you've had. Maybe the files that you've already analyzed, or you maybe want to be able to search through it. Irregardless of how long you've been doing an assessment, we want to be able to still be able to analyze and interact with that data.
And kind of with that continuity as well, if we find a new type of file that can be interesting, or a new way to parse something, or a particular known format that we can pull a password out of or decrypt something, we want to build modules for that and actually enable all operators across the board to do that indefinitely. So that was kind of the vision that Lee laid out. I'm going to talk about just the file triage problem. So Nemesis, originally, we'll get to the 1.0, kind of originally the problem it tried to tackle. We have reduced it down with the rewrite to focusing purely on file triage. So I'm going to talk about some of the challenges in offensive file processing that we tend to do on engagements, which anyone that's done pen test and red teams, this will probably be a little bit familiar. So I'll start with my definitely not AI-generated red team storytime graphic. I drew that myself. It definitely wasn't ChatGPT. But let's say we're on our op, we have our agent. This is Cobalt Strike as an example. We're going to download our program.exe, something that seems like it might be particularly interesting after we do our file listing. It downloads everything to the actual team server itself. Then we're going to have to sync everything from that team server component back down to our analysis system. We're like, okay, we do our super awesome advanced run file analysis on it. We see it's a .NET assembly. It's something we tend to look for things like deserialization vulnerabilities. Like, okay, well now I can't just open that straight, or I can't do decompilation and that kind of stuff straight on my Linux ops system. I need to then take that and move it over to a Windows VM. I need to then open that up in a different thing in a different channel, open everything up, and start analyzing all the source code. And I see there's a JScript evaluate, some kind of command injection or something like that, right? So that's not too terrible to do all that, but there's a lot of moving pieces, a lot of things you have to move across different systems and tools and VMs. And when you're trying to do that, 10 or 100,000 times, that starts to get kind of onerous, right? And gets a little frustrating, or it can be just time consuming. This kind of tool fragmentation is a real problem, right? To where, and I know there's several projects, and Harbinger and everything yesterday, we talked about some of these same types of things. We'll touch a little bit later, kind of a bit of the difference between the projects, or how they kind of can potentially mesh together. But just this is another example of, you know, you're pulling a Office document down, it happens to be encrypted, and then we need to pull down our Office to John, pull hashes out, and then feed it to a cracking rig. There's just lots of little steps that are not necessarily difficult or intellectually challenging. It's just something we manually have to do lots of times, and we don't like that.
In aggregate, all of these small little steps that we have to take really do end up taking a lot of time and a lot of mental energy. So we're trying to get rid of that, and so that we can focus on the interesting problems at play inside of networks.
But again, the reality of these modern red team kind of operations as far as file processing goes, file analysis tends to be painful for most teams, if not all teams. It's almost always kind of a manual and consistent process to where different people or operators might use different tools across different VMs. Some people might remember to do certain things or not, depending on your playbooks or what automations you might already have. Tool fragmentation, like we mentioned, is a real problem across different systems and tools and platforms and ops and VMs and Docker containers and everything else. And then also just insights tend to be lost across multiple team members unless you manually input everything into some kind of collaboration platform, to where if you download all these files and you're syncing them from Cobalt Strike or whatever C2 platform you have, multiple operators might be syncing stuff down and analyzing the same files, and now you're having duplications of effort. And it's just, again, that's not the craziest, coolest, zero-day pwn stuff kind of problem, but file triage is something we do on almost all engagements, and it's just a lot of pain points. So in comparison, defenders have VirusTotal, right? So it allows you to automatically run a lot of your different analysis engines on IPs, URLs, files themselves. These are kind of like their enrichments, right? Where you have different engines that you just submit stuff up, whether through an automated pipeline or whatever else. You're going to get the same analysis across every single file. It's consistent, right? You're going to get those same engines. You're also going to get a lot of metadata kind of analysis breakdown. So it's turning these files into structured data. So you have, this is Rubius that got submitted, file versions, copyrights, metadata tags, like signatures, all those types of things. This is all put into a structured format that defenders can analyze and aggregate across everything. So we don't quite have something like this on the offensive side. Also, there's collaboration. So you can have comments and things like that. This was Rubius that got submitted. There's this nice little thing that Florian decided to put up with Thor that the author has shared this with the community with the intention to improve overall security. P.S. We did, Florian. That's why we wrote this, but that's a debate for another time that I'm happy to talk about later. But the requirements for offensive analysis, that's a bit different from defense. We care more about finding credentials and interesting information rather than malware, rather than identifying particular threats. Obviously, we care if we find malware on an engagement, right? If we're cohabitating or something like that. But in general, we tend to say, or we tend to care about what's interesting from these files and how can I use it to further my engagement. We're going to hit a lot of different various proprietary formats and configs. So it's not as much of a focus on just like EXEs, DLLs. We're going to care about all of our weird INIs and Google configs and AWS creds, and maybe there's something in an Office document or an Excel document that has like passwords for servers pulled out. There's a lot more different formats we tend to care about, rather than the kind of more isolated set of executable file formats that malware analysis tend to care about. Again, we care more about useful rather than malicious. Useful can kind of be a little bit of a gray area, or it's like, what does it mean this is useful? Is it a network diagram that gives you information on what to attack? Is it a set of passwords for a bunch of servers? This is a little bit more of a problem that things like LLMs might be able to help us start kind of addressing over the next couple of years. But there's some very obvious things like, do these files have credentials in them?
Similarly, a lot of what we do on the offensive side is just we need to look at a file. And if it's in a binary format, if it's in a database format, if it's in base64 encoded or whatever, like we still want to look and see what that is, and maybe defenders don't have that same requirement. And so if we can just create viewers of some sort to kind of streamline that whole process, it'll help us as operators. It's going to save us time.
And also, we just handle false positives differently in offense rather than defense. We're usually not touching on like millions or hundreds of millions of files or something like that, right? We might have like tens of thousands up to 100,000 or so files, depending on the context or like kind of what we're downloading from an engagement. So false positives, we're much more tolerant of them. To where from the defensive side, as information scales up, the more false positives you can have just a flood of all these things that you get that analysis or analyst fatigue, right? But with offense in general, we can be a little broader with the kind of the checks that we're scanning across everything. To where if we have 100 alerts for 10,000 files we're going through, that's probably something that an analyst can do with not too much of an issue. And so, but that's all kind of comes together in kind of the triage bottleneck, to where depending on engagements, we're going to collect anywhere from like 100 to 10,000 plus files on typical engagements. Some of the things maybe it's a zip of a GitHub repo that explodes with a lot more files or something like that. And if you're doing manual analysis, 5, 10, 20, 30, maybe whatever files per hour, depending what you're kind of doing. But the majority of files tend to not be like properly analyzed. You're going to use these kind of internal heuristics that you have to select of like, oh, I think this type of config probably has something sensitive, or maybe it's a hint from the path or something like that. But there's a lot of these patterns that all of us tend to internalize over time as we've been doing this file triage that lets us focus on what we're going to download and what we're going to analyze, instead of downloading a lot more and just having an automated process handle all of it.
Yeah, some may wonder, like, how are we even downloading 10,000 files per assessment? And like you said, we could be analyzing GitHub instances, we could be analyzing Kubernetes clusters and analyzing all the manifests in there. You have access to SharePoint, you have access into people's wikis and confluences and internal knowledge stores. All of these, when we browse these things, we typically download them as files, and then we're trying to analyze them offline somewhere else. So this is how this number really kind of ratchets up over time as you're doing an assessment. And again, it can vary assessment by assessment. Maybe you download 50 files for one assessment, but effectively after everything is decompressed, maybe you have 100 or 10,000 or 100,000 files for the next. So Nemesis 1.0. So the good, the bad, and the ugly. So back in 2023, Will, myself, and Max Harley, who's now over at Dreadnode, we released Nemesis 1.0 at Black Hat, and we've been using it ever since then internally here at SpectropOps. Maybe some of you have used it as well. I don't blame you if you didn't, but and we'll dive into why. So our original goal with the first version of Nemesis was to ingest basically everything that we possibly could and model everything that we possibly could.
So not just files, but network connections, hosts, domains, all the different stuff you would have in Bloodhound, but even like open ports connected to all these different types of DLLs and service information. We wanted a complete model of every host that we possibly encountered on the network.
Yeah, we had process tokens, all the like different attributes of process tokens, users, integrity, all that good stuff. Modeled inside of it, but it was a little ambitious, to say the least, to try and build an entire model.
Yeah, just model every single thing you possibly find in an environment. That's
Small effort to do.
And part of the vision too was kind of effectively with the Harbinger project from yesterday that they presented on. A bit of that kind of assistant platform was part of the original vision. We unfortunately, it wasn't a complete failure, but we did not achieve the success, even that they did as far as the assistance platform. But we'll go into kind of how we refocused.
Yeah. But nonetheless, it has provided a lot of value for ourselves on assessments as we've been doing them at SpectreOps. Another kind of aspect of this is it was a little complex. So we wanted it to scale up. We knew we were going to be dealing with a bunch of files. And so we started off trying to dive into the Kubernetes world, which maybe was a mistake. That just kind of shows you how complex it can get right there. That being said, like I said, there was a lot of benefits that we had as we were doing our assessments. So we got a ton of value of doing this centralized analysis. We received a bunch of feedback from our operators that they felt comfort just knowing that somebody was always watching them behind the scenes.
Well, the files are always processed in the same way, but they really kind of started to focus. The thing that they used the most was the file processing.
Yeah. In addition to that, the fact that you could view everything within a browser and just, you didn't need to download it to a machine and then transfer it over to a Windows machine or go download some random package just so you can open this up, or if it's a SQLite database, you didn't need to, not having to go and find a SQLite browser was very beneficial. It just, again, streamlined this whole process. It allowed you to go to one interface to analyze a file rather than having to go to several different interfaces. Ultimately, this was the beginning of being able to standardize the file triage process for us. And it was a good baseline. We have tons of lessons learned, which we really appreciated. And out of this too, we also started getting structured data, which we are big proponents of, so that we can integrate it elsewhere or analyze it at a later point. That being said, it wasn't all roses. So one of the challenges that we had is we wanted to support as many C2 frameworks as we possibly could, because we wanted this as one central service that a lot of people could use. Becomes problematic. One of the big problems is that most C2 frameworks model hosts and the targets that they're interacting with differently. A very simple example of this is, some people use the host name, some people use the IP address, some collect both, and those can both be used as identifiers.
Or short name versus a fully qualified domain name if it's domain joined, and trying to kind of reconcile all of those to where if you're collecting multiple agents and C2 platforms for the same host, of trying to collapse everything down to saying all these multiple agents and bits of data represent the same logical host in a network was a little bit more difficult than we anticipated.
Similarly, sometimes we'd get on Docker containers, and every time it would get deleted and then be spun up again, and it has the same host name underneath. So you may actually have 200 different containers that have been running, but they all just shared the same host name. So there's complications that come with that, and you have to architect for that. And so trying to unify all these different tools into one location inside of Nemesis was tricky for us. And honestly, there was other tools that had kind of already solved the problem. So we use Mythic a lot. It's a really great C2 framework, and he has already kind of solved the host modeling problem for us, all those challenges. So we're kind of thought to ourselves, this has been solved. Maybe we can just offload that problem and some of these other problems to our C2 framework, rather than trying to build this out again ourselves. Similarly, trying to handle every single kind of piece of data was just a big task. This becomes a maintenance nightmare, especially when you're trying to support a bunch of different C2 platforms. So
having 100 protobufs for every single type of data type, and then maybe field names change per C2 and whatever else, things just got difficult to keep up to date.
Yeah, and so Will and I, we don't get a dev on Nemesis 100% of our time in our day job, so we wanted to be able to still dev on the project, but when you're trying to maintain all of this stuff and make sure it's not breaking, it becomes a challenge, and I personally don't want to be working on plumbing and bug fixing all day. I want to add new stuff. So it was getting hard there. Kind of on that same note, the extensibility was a little rigid. So when you wanted to add something new, it was kind of a process for a few different reasons. The schema we had was painful to work with. When you tried to modify it, it would cause problems. We had a complex dev setup. Part of that was due to the Kubernetes world that we were working in. And a lot of people are just unfamiliar with Kubernetes, using it in general, let alone developing in Kubernetes environments. So that was kind of painful as well. And ultimately, this just comes down to it wasn't hackable for us, enough for us. We wanted to be able to, take a few hours here and there that we have throughout the week and be able to actually build something out, quickly add something in or do a bug fix. And we weren't able to do that. So we took a step back and kind of tried to reevaluate those things. Similarly, we wanted scaling ability, but we aren't microservice architects by any means. We have a team dedicated to this who work on Bloodhound, our Bloodhound Enterprise product. And we don't do that because it would definitely tip over if that were the case. So this just added complexity to the whole situation, more overhead, more maintenance, and just sucked time away from working on interesting things rather than instead we were working on kind of more boring things. Finally, kind of the ugly part of this whole thing was the UI. So the dashboard is the main thing people would use, and it was not the best. We both aren't front-end devs, or maybe I can say we weren't front-end devs, hint, hint, a little foreshadow. And then we were using a framework called Streamlit, which is great for quick POCs. A lot of the data science world uses it. However, we quickly started running up into limitations with it. Similarly, we weren't UI or UX engineers, so some of the workflows and kind of how you interacted with things was painful, and it probably showed if you used the tool. Nonetheless, it was useful. I'm not trying to completely put it down. So ultimately, this being the main experience for people was not ideal and led to some frustrations when people would use Nemesis. So that led to earlier this year in December, Will and I, there's a bar near where we work, and that's where we like to go and have our conversations. So that's us. We decided to take a step back. We wanted the project to keep on going. We wanted to keep deving on it. And so we took the approach of, all right, let's take a step back. What is it that people find most useful from our project? And we're going to just scrap everything, ditch out all the extra cruft that people don't use or it's not as used as often, and focus on what it does best. And that ultimately was the file enrichment stuff. And that's not to say maybe at some point we'll go back to focusing on other data types, but we really wanted to focus in on just file enrichment for now and focus on that and make it really, really good. So it's a complete rewrite from the ground up.
Probably 90 to 95% of the code is new. So there are small bits that were kept, but we basically threw almost everything out, took a chainsaw to it.
Yep. And then we really wanted to focus on the UI and the workflow and the experience that the operator has. So we came up with a new UI that we'll talk about in a little bit. And ultimately, it's just more streamlined. So it's going to be easier to dev on. It's simpler, a lot more intuitive on how it works underneath too.
Cool. So I'll show you the new stuff, all from the ground up. So there's a bucket of major changes that we're going to talk about. We don't have time to cover every single little bit that's changed. But one of the big things is we have a simplified architecture. So we fell back to Docker Compose. So there's less overhead. We might revisit Kubernetes at some point over the next 6 months, 6 to 12 months. But if we do that, it's going to be with advice and collaboration from the Kubernetes engineers that we have on our enterprise side, so we know we actually do it correctly. We also integrated something called Dapper. So I know Roberto from yesterday, he's a big fan of Dapper. It's the distributed application runtime. One of the components that Dapper has is repeatable, durable workflows that we're going to talk about. It has a lot of other building blocks. It has like service-ification, like pub-sub abstractions, and it's a way that you can, it's a lot of just useful pieces that you can build in for microservice-based architecture. So we use a lot of different components of that.
So ultimately, like, we really liked this because it saved us from having to do a lot of infrastructure plumbing work and maintenance. We can just instead be like, Dapper already does this for us. We'll let it worry about it, and then we'll focus on the interesting things.
So the old version of Nemesis, when we wanted to replace Kafka with RabbitMQ, that was like a 1 to 2 week process to actually rebuild everything. For the new version, that would take 5 minutes, that you can swap it out as an abstraction with Dapper. We also have a completely new UI that we're going to show. It looks really nice. It doesn't look like the crappy Streamlit stuff, and it actually works. We're going to show several demos of that. And we just have a lot of workflow improvements. So we try to focus on kind of findings, so things that, what our operators actually care about. We talked to dozens of our operators of saying, like, what would you actually want? Instead of just Lee and I sitting in a corner saying we're just going to theorize what everyone should use, we actually took a ton of feedback from people over several months through a lot of these different iterations as far as like enrichment module ideas and just general kind of workflow. So with the architecture, we only kept code and services that were necessary. We have no more Elasticsearch. We have no more Kubernetes. We have no more protobufs. Everything's much more simpler, much more flexible. So this, everything's a trade-off, right? But we felt like moving towards a simplification to let you actually hack on everything and build stuff and expand it much more easily is something that hopefully people here might actually contribute to the project. And the entire code base is just much, much simpler and much easier to understand. It's much smaller. So hopefully it's, you're not just diving into this crazy Kubernetes like giant ocean that you're trying to figure out what's going on. It should, in general, hopefully make sense to everybody. Again, we have Docker Compose. So this also gives us ARM support. So I've got my trusty MacBook. Lee has a Windows laptop. We both have been developing on this, and we actually just rebuilt everything this morning. So it works on ARM. It'll work on Mac. It'll work on Windows. And let's see. Yeah, it's just easier for like a dev environment. And again, like I mentioned, Kubernetes will likely be reintroduced to some degree in the future, but we always want to keep the Docker Compose like dev type approach to where if you just want to run this on a single system without having to stand up a Kubernetes cluster locally or remotely, you'll be able to run it just on your host.
The main reason behind that is just so we can increase the throughput and how many files we can analyze. Yeah. For reference, like yesterday I was just doing some testing on a little mini PC I had, and I threw in, I think, like 12,000 files, and these were just text files, which go really fast, but we were able to get through it in about a minute for text files. Depending on the data types that you're working with, it'll go a bit slower, but ultimately the throughput is actually quite good, even without scaling.
Again, it will depend on the exact files you input, but yeah. So Dapper, the distributed application runtime. So I kind of mentioned there's lots of different abstractions in Dapper, lots of different cool pieces. You can abstract like service-ification, the pub sub, you can swap out, different like online message brokers versus RabbitMQ versus Kafka and whatever else. It's just like a little configuration change. And again, this is all the annoying plumbing that we didn't want to have to spend time developing. There's observability, monitoring, state management, all this kind of fun stuff. One of the big things is workflows. So there's, I think, the Harbinger project uses temporal. There's like Celery. There's lots of different workflow type frameworks. They all have their trade-offs, like good and bad. We felt like we're just a bit more familiar with Dapper, especially after being introduced to it by Roberto. So this gives you the ability to run these repeatable, durable type sequences of action. So you define these as code, and this also gives you scaling to where workflows are built on what's called actors in Dapper, that as you scale up to something like Kubernetes, it can distribute the actors amongst a ton of different nodes, and it just gives you a really nice like parallel processing, like throughput type thing. So there are people that use Dapper in like large organizations for like running millions of workflows at one time. So it is proven to be scalable.
It's a CCNF project, so there's a lot of dev support behind it too, and it's not going to go away anytime soon. It's not just a commercial offering.
We also have, this is the new UI interface. So it looks nice now. It looks all hackery. And we have light mode and dark mode, which is the most important thing that everyone always yells at us for. Yeah, this is good, yeah. The coolest features, light mode and dark mode. We'll show this kind of in the actual demo video that we go through, but we have like overviews, files, our findings, document search, YAR rules, and all these pieces that we're going to talk about. And then, so the UI interface is completely done in React, no more Streamlit. There's custom file and there's like custom file tagging and filtering systems. We have the options for keyboard-only triage, which our boss Alad was like, you have to put this in because I hate having to click through everything. So you can do all your file and finding triage without moving the mouse. There's a file feedback system to where it can actually, like if your operators find a file that you don't have an enrichment for, or you want to leave notes or say we need some kind of processor for, there's a nice little feedback system that will then optionally plug into like Slack webhooks, so you can have a channel that just gives like all the feedback of like, hey, you need modules for this or whatever else. We have better file and finding filtering. We have different file viewers, like viewing the SQLite databases in the browser, or zip files, if they're under a certain size, can be unzipped in memory, and source code can be browsed through, and we'll show that in a demo. And we have like lots of nice different like kind of triage tracking to where as you view files by default, it'll say these are viewed and like hide them from the interface from everybody. You can like still make them all appear again. We'll show that again, but it just makes it really nice. Or if you have multiplayer kind of coming in and everyone's triaging files at one time. The file viewers, we have like, oh, okay, so simple things, Office documents can be converted to PDFs. If you have canaries in your documents, they will not trigger during the PDF conversion. So that's something we've been caught with before for, was it the canary tokens type stuff or for different file formats. So the way we do conversions, we've tested, they don't appear to trigger. And people don't have to sync these down and open up Open Office or Word or whatever else for Excel, for PowerPoints, for Word docs. Also things like plain text are extracted. You can view just the raw hex of files. You can view strings, just that are extracted from files.
It's all searchable too.
Yep, everything's searchable. We have SQLite in browser viewing. So this is like a Chrome history file. We'll show this in the demo as well. You can do raw SQL, do your queries, pull stuff down.
Something to keep in mind there too is it's not just specific to Chrome databases. Yep. It sniffs the file content, and if it's a SQLite, if it's for some third-party product, you can also browse the database in there too.
We have Monaco in-browser code syntax highlighting, which is the engine behind Visual Studio Code. So files themselves, if they're sniffed, if the formats are sniffed and they can be viewed, you'll get like nice syntax highlighting. But also, if you have a zip file that has multiple source code files within it, if it's under a certain size, it'll temporarily extract it in memory, and you can just browse through and actually just have all your files right there without having to pull stuff down. We'll show that in the demo. We have our findings focus. So enrichment modules have the option to emit findings. So this could be Nosy Parker results, Yara scanners, maybe there's an extracted hash from a PDF or Office document, DP API blob identification, PII scanners, like whatever else, lots of different options here. We also have things like, we validate, so if a JWT is extracted by Nosy Parker, we actually decode it and like validate the time to see if it's expired or not. And then we'll mark that as a finding, but a false positive finding. So we have like false positive, false negative, and needs review. We have the option, we have the plumbing for people to do like automatic analysis of this too, whether through LLMs or something else, which is something we're going to explore in the future. Then we have like the details for natural finding, gives you all this stuff. And then up at the top under file path, and we'll show this in the demo, you can go to the file that this finding originated from. We also have dynamic YAR rules. So we have a YAR rule engine in the backend that every single file is scanned for. You can, through the web interface, just generate new YAR rules for regexes or strings. So let's say you find out you need to go after project X for a client. You can spin up a new YAR rule without having to tear everything down. Just hit save it off, and then every single file and text extracted from any applicable file will have that term scanned for, and alerts will be filtered. Similarly,
you could use it to scan for creds if you even wanted to.
We also have, we didn't even mention it here, we have a more robust alerting system using the Apprise alerting package. So not just Slack, but Mattermost, Discord, whatever you want to basically alert on, you can configure it to actually have any of the findings will actually be alerted to your centralized queue. We have CLI improvements, so everything's Dockerized. So like the CLI is purely a Docker container that's built. So all of our connectors are much simpler to set up. For right now, we have Mythic and Outflank for the stage 1 C2, as well as submitting files. So we can just say, like, we're going to connect to Mythic with a couple of settings and a YAML, and then every single download that's coming through is just going to be auto-ingested in. So it's much simpler to do. And we have documentation. All the docs are live again. We redid all the documentation. There's a ton of different stuff in there. I'll go a little faster. So also, we have a lot more file enrichment modules. There's currently, I think there's actually like 28 or 30 now. But you can build your own file enrichment modules. Just drop them in to the file system, and when the system starts back up, they'll be auto-loaded. You can have if you need custom dependencies, you can have your own little poetry kind of install. We have a guide, a development guide that's on there. We're going to have a more intense development guide through a blog post that will come out. And now I'll show the demo. OK, we do have some zooms. I know the text is a little small. This is the main interface. We're going to show just uploading a handful of files. So this also could be done like through your C2. It's going to process this with findings. We have, let's see, the first one is a Yara match. So we're going to, we can filter all the findings by like triage states, categories, severities, all that kind of fun stuff. Let's see. All right, if we're going to click it, we have just an example, password 123 bang for a Yara rule match. It's going to show you the rule. It's going to show you the exact location for the match. Then you can click and navigate to the file. So this is a plain text file that is linked to this originating file. So this is plain text that was extracted from a Word document that had this Yara rule trigger for it. So you can see password 123. So again, nothing super crazy, just simplifies a lot of these steps that you're doing. Let's see, we have .NET vulns. So we run deserialization checks on every .NET binary that comes through. We're going to go to the linked file again. We see all of our parse metadata, just like our little VirusTotal stuff. Then we can say view decompiled source code. So this is automatically decompiled to a zip that then you can navigate through with your Monaco code editor. And we have our same JavaScript evaluate right there. Everything, all the syntax highlighting hits in. Then finally, we also have, this is just looking through files. This is one of those Chromium history SQLite databases. It has a nice little summary of like top visited URLs. You can like pull down the URLs and downloads as CSVs. There's like a schema dump, but then you can view live all of the SQLite data just in the browser without having to start anything back up. And we'll show the downloads. This is the schema. I'll show you the downloads themselves. And then finally, like when we did the files, as you view the files, it marks them as viewed. But you can still view everything there, but as multiple people are going through, it's going to mark these as viewed by each individual operator. All right. Cool, thanks.
So that's what it is now, and this is also only a fraction of what it does. There's limited time, so we can't touch on everything, and there's definitely going to be more. So the current state, the core plumbing is all there now, thankfully. So we can just start adding fun new features. Everything that we had in the previous Nemesis, all the enrichments that we had have been added, and we've added, 10 or 20 new file viewers and enrichments on top of that. So it's already much more.
There's more functionality than what the previous version had.
Yeah, by far. New interface, much better, much more functional. Documentation, as Will said, has been pushed up already.
It gets auto-published to GitHub pages.
Yep. The UI process, so you can get alerts through Slack, or you can submit feedback. So as operators are going and are like, hey, this would be good for other assessments. For example, we had somebody the other day mention that they wanted some K8s parsing inside.
Like manifest parsing.
Yeah, manifest parsing. So they submitted some feedback to us. Data expungement, so after a certain expiration day, it'll delete any data inside of Nemesis.
It's a housekeeping process that runs periodically that you can specify, and everything has an expiration, so you don't keep any sensitive data kind of indefinitely.
Yep. And the alerting, as Will already mentioned, too.
We almost have all the containers auto-building. We're just working out a couple of things. That'll be within the next week or two. We'll have all the containers auto-building and pushing up to the GitHub container repository.
Yeah, so that's what we have now. In the future, as I mentioned, we're going to definitely add some more file analyzers. Like that's honestly the easiest thing to add, and we can do it super quick. LLMs can do it super quick. We've used them a lot already for a bunch of data types.
We say this in the development guide. Just take an example file enrichment, like analyzer that you already have, like drop it into ChatGPT or Claude, and then say, I want you to do this type of format, but then with this like PowerShell-based parser, and it'll get it like 98% of the way there, if not 100% of the way there, pretty quickly.
Or you can just give it an example file like that you want to extract data from, and then give an example enrichment class, and then it'll spit out for the most part what you need. Like we said, we are going to explore K8s again in the future. That's again just to scale up the deployment more. More performance optimizations. Like I said, it does go pretty fast already, but we're going to keep improving that, especially on huge data sets. AI, AI is all the things, so we're going to work on some AI integrations for one, analyzing, and then two, for some of the triage of any of the findings that we have.
False positives, that type of stuff.
But we will say we are very practical with our AI stuff. We were just kind of ranting about this earlier to somebody. We don't have unlimited inference costs, unfortunately, and so we do have to keep in mind that we can't just shove everything into an LLM. So we are looking forward to the optimization and problem solving we're going to have to do for that. In addition, more workflow and collaboration features. So just trying to streamline, again, this analysis as a team as much as we possibly can. And how we kind of, envision red team ops in the future. Humans definitely still involved. We want them to, be able to analyze every single file automatically and have an assurance that in the background, anything that they've downloaded has been looked at in depth. We want this additional AI assistance in the back end too. Like you mentioned, enrichment and triage. As we're doing more and more assessments, we want this knowledge to be shared within our own team. We're sharing it publicly as well, so hopefully others can benefit. Hopefully you can benefit, contribute back as well and help us. This is one of the great reasons why we love open source, is so that everybody can kind of benefit together. And ultimately, I like focusing on interesting problems and solving interesting security things. And rather than dealing with annoying things like converting to different formats or just opening up files in different applications. So I'm excited for people to work on interesting problems rather than annoying manual triage. And of course, all of this is going to be used for more and more research in the future.
So we pushed all the code like 2 hours ago. It's public in the Nemesis repo now. It's the new 2.0 branch. All the documentation, which is linked on the side in the public repo, it's all live. It should work. We tested it, but we're going to pay attention to all the feedback, especially for the next couple of weeks from people. We want to make sure this works for everybody. We want it to be way more usable. We're going to be releasing some blog posts in spectrops.io in the next few weeks. We also have a Nemesis chat channel in the Bloodhound Slack. The Ghostly link is the invite for that. And thank you guys for allowing us out here. And thank you to the ZeveCon organizers for everything.